Now we're going to write the names of ionic compounds. Naming binary ionic compounds from the formulas, all binary compounds, ionic or covalent, end in "ide", I-D-E. When naming binary ionic compounds with metals that are not transition metals, like groups 1A, 2A, and aluminum on the periodic table, you just write the full name of the metal and then write the root of the nonmetal and then end it with a suffix of "ide". For example, Ca is calcium, and then instead of chlorine, this will be chloride. Li is lithium. Instead of nitrogen, this will be nitride. So what is the name of the compound MgBr2? Mg is just going to be magnesium, not to be confused with manganese, which is Mn, so watch out for that. So it's going to be magnesium, and then instead of bromine, it's going to be bromide with the IDE at the end. And so C is going to be our correct answer for this question. When naming binary ionic compounds with transition metals, you have to figure out the charge of the transition metal and then show that with a Roman numeral. For example, CuO, it's not just copper oxide. Since this is a transition metal, it's going to have a Roman numeral to indicate what its charge is. So because it could be Cu+1 or Cu+2. So we have to do a little bit of math to figure out what's the charge on this copper. Oxygen is always a -2 charge. The total negative charge overall is -2 because we only have one oxygen, and therefore to balance it we need an overall +2 charge, and since there's only one copper, that one copper must have a +2 charge, which is going to tell us it should have a Roman numeral of 2 in the name. This method is called the box method. You'll use this method to determine the charge of a transition metal, with the exception of silver, cadmium, and zinc, which only have one charge each. +1 for silver, +2 for cadmium, +2 for zinc. So if we have a +2 charge on the copper, it means we're going to write a Roman numeral 2. So the name is going to be copper, Roman numeral 2, and then oxide. So take a moment, pause the video, and write the names of each of the following, then unpause the video to see the answers. Here are the correct answers. Na is just sodium, and then N instead of nitrogen will be nitride. Al is aluminum, and then O is going to be oxide. K is potassium, Br will be bromide, and then Mg magnesium, and then S sulfide. Now use the box method to figure out the Roman numeral that goes with each of these transition metals and then write their names. Pause the video and then unpause to see the answers. For PbO, we're going to use the box method. First, what you know is your anion, oxide, from the periodic table has a charge of -2. That gives oxide an overall charge of -2 times 1, a subscript of 1, equals an overall -2 charge. That means that we need an overall +2 on the lead. Since there's only one lead, that means that 2 divided by 1 means this lead has a +2 charge. And so that makes the answer lead, Roman numeral 2, oxide. Next we'll do COCl3, and what you know is that the chloride on the periodic table has a -1 charge. -1 times 3 is a -3 overall, which means I need a +3 overall. 3 divided by 1 cobalt equals a +3 on this cobalt, so the name of this is cobalt, Roman numeral 3, and then this is chloride. This one will be more challenging. Cr3p2, and what we know is the phosphide has an overall -3 charge. -3 times 2 is -6 overall, so I need a +6 overall. 6 divided by 3 equals 2, so that means the chromium has a +2 charge overall, which makes this chromium, Roman numeral 2, and then phosphide. Finally, NiN is nickel nitride, but what's the Roman numeral? What I know is this is -3. -3 times 1 is -3, which means this must be a +3. +3 divided by 1 nickel means that it's +3, and so this is nickel Roman numeral 3 nitride. Now you give it a try and write the names of the following compounds and then unpause the video to check your answers. So this is going to be iron, looking here, Roman numeral 3, and then oxide. If you use the box method, you'll see that this is a -2. 2 times 3 gives me an overall -6, which means this should be a +6. 6 divided by 2 means that this is a +3, so this is iron 3 oxide. Here we have cobalt, and then I'll look there, and it's Roman numeral 3, and then that's chloride. Again, if we use the box method, we can see that the chloride has a -1 charge, which gives me an overall -3, so this must be a +3, and since there's only one, then it has a +3 charge, which makes it cobalt Roman numeral 3. Now this one, because there's no subscript here, we absolutely have to use the box method. So it's nickel, and then there's some Roman numeral, and then this is sulfide, and the question is, what is the Roman numeral? What we know is that sulfide has a -2 charge, which gives me an overall -2, which means this must be a +2, which gives the nickel an overall +2 charge. So this is going to be nickel Roman numeral 2 sulfide. This is lead, and then I can use that to know that it's lead Roman numeral 4, and then Br is bromide. Okay, this one is iron. Use that little 2, iron 2, and then bromide. Now, this is one of those tricky ones. Put a star. Because there's no subscript here, that means I do have to do the box method. It's going to be copper, some Roman numeral, and then chloride. And then we'll use the box method to figure out what is the Roman numeral. I know chloride is a -1, which gives me an overall -1, which means this must be a +1, and since there's only one copper, it must be a +1. So that's going to be copper 1 chloride. Very tricky. This one is also quite tricky. We're not going to be able to use that little trick where we use this 2 down here, and I will show you why. So this is going to be tin, some Roman numeral, and oxide. And we have to use the box method because we get a -2 on oxide. -2 times 2 is an overall -4, which means this must be a +4. Since there's only one tin, then the tin has a +4 charge, which means my Roman numeral is 4. This is a very special scenario. It only happens with tin and lead, and so you would need the box method here. Lastly, we don't know the Roman numeral. There's no subscript here, so we can't use a subscript. So it's going to be iron, some Roman numeral, and then phosphide. And then if I use the box method, phosphide is a -3, which means I have an overall -3, which means I need an overall +3, and since there's only one iron, then it's going to be a +3 charge. Therefore, it is Roman numeral 3. So what you may have noticed is that if we have a little subscript on the end, that tends to be the charge of our transition metal. If there's no subscript, that means we have one of each, then that tends to mean that whatever the charge is on the anion is the charge of the cation. But it's always best to use the box method because you're guaranteed not to get it wrong that way. Put it all together now. Write the name of the metal first, then write the name of the polyatomic ion. If the polyatomic ion comes first, name it. If the compound ends with a monoatomic nonmetal, then you're just going to change the ending of that nonmetal to "ide." So for this first example, it's Ca, that's my metal, calcium, space, then in parentheses I have a polyatomic ion, NO3 is nitrate. So the name of that is calcium nitrate. Next metal is sodium, and then the rest of this is my anion, and so that's a polyatomic ion. If it were SO4, it would be sulfate, but since it's SO3, it's sulfite. NH4 is a polyatomic cation, and it is called ammonium. Then Cl is a monoatomic nonmetal, so I'm just going to call it chloride. This copper is a transition metal, so we can't only call it copper, we have to give it a Roman numeral. And if we look down here at this little 2 subscript, it's a Roman numeral 2 copper. So copper 2, and then this polyatomic ion in parentheses is acetate. So now I would like for you to pause the video, attempt to write the names of all of these, and then unpause the video to check your answers. Let's go over the answers. First is ammonium sulfide. Ammonium is NH4, that's a polyatomic ion, and then S is a monoatomic ion. It's just one element, so it's going to be end in IDE, so it'll just be sulfide. Next is copper. It's a transition metal, so it needs a Roman numeral. We look here, that's going to be copper, Roman numeral 2, and then this ion in the parentheses is hydroxide. This one everything has a cation and an anion if it's ionic. So the cation here is NH4, that's ammonium, and then the anion is NO3, that's nitrate. So this is ammonium nitrate. Next, copper is a transition metal, so it has to have a Roman numeral. You're going to have to use the box method with this one. Because the sulfate has a -2 charge, the copper must have a +2 charge, and so this is going to be copper 2 sulfate, because we have only 1 copper to 1 sulfate. Next is iron, and it is also a transition metal, so it must have a Roman numeral, and we can't use this little 4 down here because that belongs to the phosphate. It's not how many phosphates there are. There's only 1 phosphate. So because there's only 1 iron and 1 phosphate, the charge of phosphate is equal and opposite the charge of the iron. Phosphate's -3, so the iron must be +3. So this is iron 3 phosphate. The cation is ammonium, and then the anion is monoatomic, so it's nitride, IDE. Barium is our metal. We don't need a Roman numeral because it's not a transition metal. And then in the parentheses, instead of it being phosphate, which is PO4, it's now phosphite, ITE, because of the 3, because it's PO3. Next is iron, which is a transition metal, so it has to have a Roman numeral. Lucky for us, we have this 3 outside of the parenthesis, so that indicates that this must be a +3 charge. And so this is iron, Roman numeral 3, and then SO4 in the parentheses is called sulfate. This is strontium, no Roman numeral necessary because it's not a transition metal, and then this is hydroxide. Copper is a transition metal, so I need a Roman numeral. Lucky for us, we have parentheses and a little 2. That 2 tells me the charge of copper is Roman numeral 2, a +2 charge. So it's going to be copper 2, and then this PO4 is phosphate. This iron is a transition metal, so I need a Roman numeral, and because I have parentheses and this 2 on the outside, that tells me this is iron, Roman numeral 2, and then in the parentheses, ClO3 is called chlorate. That's the name of that polyatomic ion. Lastly, potassium is the metal. It's not a transition metal, so I don't need a Roman numeral, and then PO4 is a polyatomic ion called phosphate. Now, pause the video for just a little more practice and then unpause the video to see the final answers. For the final answers, you can check them. Pay close attention to when there is a Roman numeral and when there is not. Also notice that all of the names only have 2 parts, the cation and the anion. And now we'll do some homework on Canvas.